So number 6. Sometimes to decide what quadrant you're going to draw a triangle in, they give you an ordered pair. You travel there, left, right, up, or down. Sometimes they just say it's in quadrant whatever. This is a certain way, which I'll go over. And there's another way, which I'm going to show you on 4 or 6, I can't remember, on the calculator portion. But anyway, this is telling us that sine is negative and cosine is negative. It's giving us the SIGNs of sine and cosine. So what I like to do is use my all students take calculus trick, and this is not something I need to see. This is what I do. Some of you can just kind of get rid of all the ones in your head. You don't have to use this, but this is what you would be doing. You're thinking, okay, I need to find the one quadrant where these are both negative, okay? So remember, all students take calculus represents who's positive. So all are positive, so it can't be there. Sine is positive there, cosine is positive there. So we know that this means quadrant 3. So then you're going to sketch a triangle in quadrant 3. Okay. So remember, you draw your hypotenuse out into the middle of the quadrant, right angle with the x-axis, and theta is always at the origin. And we have to know SOHCAHTOA. I think SOHCAHTOA is in section 3.2 when I went over it, but Google SOHCAHTOA, and I'm sure you can find more information about it. But the important point I'm trying to make here is that we have to know the relationship between the 3 sides of a right triangle. We need to know it here for sine, cosine, tangent. We have to know it for Pythagorean theorem. And so wherever theta is, your hypotenuse is always the longest side. It's the diagonal. This other side of the right The other side of the right triangle that makes that angle is your adjacent side, and the side that's opposite the theta is the O. Okay, so we have to know those representations, and then we can label according to what was given. So we're done with that. We don't need that anymore. But cosine is adjacent over hypotenuse. So I'm going to the left, so that would be -2. And the hypotenuse is always positive, so it makes sense that there's one negative in that fraction. The 2 would get it, right? So done with that. What we want first is tangent. Okay, tangent is opposite over adjacent. Well, I got my adjacent. I don't have my opposite, right? This is where you would do Pythagorean theorem. A squared plus b squared equals c squared, x squared plus y squared equals r squared. Doesn't matter. As long as you know -2 is either one of the legs, a, b, or x and y. So -2 squared and 5 squared. Subtract 4. And when I do the square root of both sides, I get plus 4 minus the square root of 21. Okay? And it matters which one I'm going to use. We're in quadrant 3, and I'm going on this side of the triangle. And that's going down. Anytime we're in quadrant 3, when we go down, it's negative. So that's how I know that I'm going to use negative. So now I can fill in my opposite right here. And remember, when you have 2 negatives, they cancel out and become positive. That should make sense. Tan is positive in quadrant 3, right? So that's this answer. And all that they're saying with the point is, what is this point right here? How did we get to that point to make this triangle? Well, it's a point on the coordinate plane. We went left 2, down square root of 21. That's what that is. All right, number 9. I might have talked about this yesterday, so let me just do it kind of quickly for the video, if nothing else. We have been working with sine and cosine and where the letters are and what they mean for pretty much 2 weeks now. So we're used to seeing everything look like that. And you can replace sine with cosine. It's the same A, B, C, D. So what's happening in this problem is our argument, this is called the argument, our argument, it's like the B was distributed back in. Okay? It's like B normally is separated, but here it's not. For sine and cosine, we like to have it look like this. It just makes it easier to pull out the information we need. So I'm going to do that. I'm going to make x be by itself. It should have a 1 in front. So I'm going to take the 5 away from it, called factoring out that 5. And all that means is I'm dividing both of these by 5. It's like the reverse of the distributive property. Okay? 5x divided by 5 is x, and pi divided by 5 is just pi over 5. You just leave it. That's it. Easy peasy. There's my B, there's my C. And now we've done a million of these. I don't think anybody would get this wrong. Never have a negative amplitude. My period is 2 pi divided by B. So that gets rid of this one. And then the phase shift comes from my C. We're going to the right, pi over 5. Mathematically, that's adding pi over 5, right? Going to the right, so that's why it's positive there. Okay? So anytime this, so one more thing. Next week when we start graphing tangent, you'll see it's easier to graph tangent when it is distributed. So most of the time you're going to see tangent with your argument looking like that. And when you don't, you'll probably want to distribute it. Kind of opposite. All right, last one from day 1, number 12. If anyone has been dissecting this problem, and I had deep conversations with some kids in my 6th and 7th period about this problem, there's a typo. If that's a 7, but that shouldn't affect how you do the problem. Okay, so that wouldn't have made a difference in the rest of it. This is basically talking about waves in the ocean that are 20 feet high, and then within the waves, there's this buoy that's just like bouncing along with the waves. And the buoy's height is from 2 to 12 feet with a 6.5 second interval between each of those waves. Okay, so this is speaking to me, math language, min and max. Okay, the min and the max of that buoy. And the 6.5 seconds is my period, because that's time. X-axis is time. It happens every 6.5 seconds, right? So first thing is my amplitude. Well, one thing you can easily find whenever you have your min and your max is your midline, right? D is your midline. Remember, add them together, divide by 2, you would get 7. But that's, be careful, because look, that's not A. Midline is the D value. Didn't ask for D. But if I know that the midline is 7 and my max is 12, from 7 to 12 is 5. So my A is 5. So we got a 50-50 chance there. We want B. We know our period. So pay attention here. This is where we have to remember some really basic math that we don't normally have to do. So the period is 2 pi, B is 2 pi divided by the period, right? But without a calculator, it's a good amount of work to do 2 divided by 6.5, move a decimal point, all that stuff. Fine if you know how to do it. But remember, this is no calculator. So it's easier, in my opinion, to change my decimal to a fraction. So 6.5 is 6.5. And then I can change 6.5, which is a mixed number, to an improper fraction. Going way back here. 2 times 6 is 12. Plus 1 is 13. And the denominators stay the same. They're always the same. So 2 times 6 plus 1. That I can handle. Keep, change, flip. And that would be 4 pi over 13. Okay? So there's a lot of distractors in that problem that you don't really need. The 20 doesn't do anything for us. That equation doesn't really do anything for us. Everything we need is right here. So one of the benefits of doing these reviews, going over stuff with me, is knowing number 12 on Monday's test is going to be some weird buoy wave question, and now you know exactly what to zoom into and do. Okay? Going on to the calculator portion, I'm going to start with number 4. I'm going to do 4, 6, and 9, and then there should be time. If people have questions, I will open it up to whatever you have questions on. Okay? Number 4 is giving us some information, right? And they want us to find tan. So they're giving us cosine and this like weird little sentence telling us that theta is in between pi and 3 pi over 2. I think we've seen one problem like this. This is another way of letting us know where our triangle is going to be. This is one of those situations where I have to decide where I'm going to draw my triangle, quadrant 1, 2, 3, or 4. And this is telling me exactly where to put it. I should recognize pi and 3 pi over 2 as two of my quadrantals. And if theta is in between those two, what quadrant is my theta in? Anybody? 3. Yeah. So my theta is between pi and 3 pi over 2. So we're in quadrant 3 somewhere. I could have said theta is between pi over 2 and pi. Quadrant 2. You get the idea. Between 3 pi over 2 and 2 pi. That would be quadrant 4. So that's just code for quadrant 3. Okay? So let's draw a triangle in quadrant 3. Cosine is adjacent over hypotenuse, SOHCAHTOA. And they gave me cosine. So again, the left 7, hypotenuse is always positive. We want tan. Tan is O over A. Well, I've got that adjacent side, right? I need my opposite side. Here we go with Pythagorean theorem again. Negative 7 squared is 49. 8 squared is 64. Subtract, this is calculator active, 15. Square root of both sides, plus or minus the square root of 15. And again, you decide on your sign by where we are. So when we go down, we are negative. So there is my numerator, opposite side. And 2 negatives make a positive. And our answer is 0. Okay? Good? Number 6 is really, really easy, but you have to remember a little formula. When you're given a theta, given an angle, theta, and you're given a radius, and you're asked for an ordered pair, there's these little formulas we've used. And they're really easy to remember, so here they are again, and then you can see your answers are ordered pairs. Here's the formulas. I want x, and I want y. Think about what you're given. Maybe that will give you a hint, memory from homework you did. Radius and theta. So in both of these, you have an r, and then x is cosine theta, y is sine theta. That's the formula. And you literally just plug in. So radius was given as 9. Theta was given as negative 5 pi over 12. Same thing over here. 9, but sine of negative 5 pi over 12. And we did these types of problems, which we're about to put in our calculator. We also did it where you had an angle that was like on the unit circle. You wouldn't use a calculator on that. Pi over 6. If I was giving you pi over 6 here, you would go, oh, cosine of pi over 6 is square root of 3 over 2, and sine of pi over 6 is 1/2, and then you would do the math. But this is just typing these in. So 9 cosine negative 5 pi over 12, and 9 sine negative 5 pi over 12. And there you can see A. So these formulas. But hopefully seeing the R and the theta will kind of remind you of that. And remember, X is always cosine, Y is sine, so you know who to put here. All right, this last one. I'm going to give you a very good piece of advice, and that is to do this with me, because I can tell you there is going to be hands shooting up in all of my classes when people get to this problem, if they haven't tried it before, because there's something in it that you have to take care of. You may figure it out on your own, but I have a feeling there's going to be some people who are not here today, who don't bother watching the video to see what we went over, and they're going to get stuck, okay? So what I want you guys to do is please do this with me and start by clearing your RAM. Clear your RAM. You need to clear your RAM, because if you don't, I can't tell what you did wrong if you do something wrong, okay? So let me just read a little bit to you. As your heart beats, your blood pressure first increases and then decreases as the heart rests between beats. The max and min of blood pressures are called the systolic and, I don't know if that's the diastolic. I don't know if I'm saying that right or wrong. Pressures respectively. So basically it's saying your blood pressure reading is written in the form of the S word over the D word. And they told you it's also max this is max and this is min. Max and min. Max and min. Blah, 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 blah. Here a doctor is monitoring a patient's blood pressure with that formula. Okay? And what we want to do is find this patient's blood pressure. Okay? Really, all we're going to do, and we've done it before, I'm going to clear my RAM, is we're going to type this in, we're going to graph it, and then we're going to find the max and the min. Because look, your answers are a max over a min, right? So let's start by typing it in our calculators correctly. So everyone should be doing that. After you clear your RAM, you have to clear your RAM. So on the test day, I'm not helping with calculators. We have to know how to put this in. You can't say, where's my pi button? How do I find sine? Where's min? Like, you have to know how to do this stuff at this point, okay? So you should all have that typed in. And if you typed it in, and remember, t is the same as x. If you hit graph, you shouldn't see anything. You did it right, you shouldn't see anything. That's normal, okay? So make sure you type it in correctly. And the reason we don't see anything when we graph this, you guys, is because let's think about what our answer choices are. When I talk about min and max, is that the x or the y value of an ordered pair? Why? Remember, min and max is how high or how low you go. So these are y values. If you go to your window, your y values go from negative 10 to 10. Our lowest is 88, and our biggest is 140. So we have to change our window on our y values to include those numbers, okay? So I'm going to go down to my y's and do that. Now, I'm not going to put 88 and 140 because that's just going to hit the very top of mine. You want to give a little space. What's the right answer here? There's not only one, okay? I did like 50 to 200, but is that the only choice? Of course not. You could do 75 to 150. I just made it that's just what I did, okay? So you choose, you can do something different than me. It doesn't have to be the same. And then and I don't like to mess with too much to begin with, okay? I don't want to change too much because this will help me decide if I need to change anything or if I didn't go high enough or something. I only want to change one thing at a time. And so mine looks like that. And to be honest with you, that's good enough. But I know some of you don't have a graph that looks like that. Is that true? Okay. Let me run it over to you. Here. You can have my heart sunglasses if you want to. I don't know. Oh, that's what yours looks like? Oh, that's really good. Is that what all of yours look like? You guys all have a graph that looks like that? Stupid. That's stupid. Why is mine not so nice? Because what? Where?
It's because she has the newer calculator, I think.
Your X.
Yeah, ours
That's so weird because I cleared my RAM.
Well, no, we're X resolution.
You know what I think it is? I think my calculator tries to adjust on its own.
Yeah.
I don't know. Go ahead.
Oh,
No, you can have these. Want them? So cute on you.
Thank you.
Yeah. So guys, listen. Mine is fine, okay? But let me just talk about, and yours is fine, clearly. Yours is even better than mine. These are all maxes and all mins. It doesn't matter which one I choose, and do that in a second. But sometimes I feel like, ooh, that's a little close together. So if I could leave it, but I could also like shorten this up a little bit so that they're a little bit more spread out. So I'm just kind of telling you different things you could do. But anyway, now that you have a bunch of maxes and a bunch of mins. It doesn't matter which one you choose. Actually, the calculator will do it for you. Let's go to calc. So second calc. Remember, this is where we go to find the 0, which is the x-intercept. We've done intersect 5 trillion times. And min and max we've done too. I'm going to go to max first because it's my top number, which is number 4. And your cursor will sit somewhere. Just make sure it's to the left. See, it says that's left of one of your maxes. Hit enter. And you use your right arrow and get somewhere to the right of that max and then tell it to guess. And you should get 136. Some of you will get 135.9. Bottom line is it rounds to 136. And guys, that's the only one that has that, which makes me nervous as a test taker because I'm like, wait, she's trying to throw me off because there's 2 138s, oh, but there's 2 88s. So just piece of advice, if you feel like you did that right, maybe move on because you still have an FRQ to do if this was test day, and then go back to it if you were feeling like, I just want to check if my min is good. And so you could still go and do your min, which is the same idea. So enter, get to the other side of your min, enter, enter, and you can see I got 88 as my denominator. Okay? Do we get that? Are we good? And I can tell you in first period, I hadn't done it since last year, so we were messing with our windows forever, and then we were like, oh, okay, as long as we just change the y. So this is what I'm talking about. Doing these problems with me is a benefit to you. You can watch this video again Monday night if you need to, if you want to go over those 3 problems on the calculator portion. Monday's non-calculator. You guys, we have a little bit of time. If anybody wants to ask me for help on any other problems, this is your chance to ask. If there's any you want me to go over. Jackson? Yeah. Okay, so let's talk about this FRQ. We're going to, I notice that it's a cosine graph. Okay, that's the first thing I look for. It's cosine. Cosine has to start either up or down. So I have choices, Jackson. Up, down, up. I'm just going to pick one of them. It doesn't matter. How about this one? Okay? That's important. My first point. I know my first point. Midline is the next thing I like to do. Midline is this number here, 0. From 0 to 5. Amplitude is 5. Does that make sense to you? Remember, it's vertical distance between my midline and my amplitude, so I look at my y values. So from 0 to 5 is 5. Okay? And then I decide, is it a negative? That's where you look at your first point. Shh, guys, I'm still teaching. You don't have to listen, but just quiet for a second. This is up, middle, down, middle, up. No negative. Okay? If I had used this as my first point, it's down, middle, up, then my 5 would be negative. Okay? Next thing, period. That's my distance from here to here. Any 5 points, I'm going to use these 5. 1, 2, 3, 5. So it's 5/8 minus 1/8 is 4/8 or 1/2. Now this is a calculator one. I don't think it's a fraction on the test, but you could have used your calculator on this. So my period is 1/2. You good on that, Jackson? Okay, but I need b, which is 2 pi divided by 1. Keep, change, flip. 4 pi. Now you all look at your individual first point. Most of us probably would have picked this one, but whatever it is, and you say, how far from 0 am I? I'm to the right 1/8. That's what it is. 0 would be to the left of this point. So to the right is negative. Does that make sense, Jackson? If this had been my first point, remember the 5 would have been negative, and my C would have been negative 3/8. The only difference. Okay? Then from K to P, which is right here, positive or negative refers to the sign of my y values. My y values are positive, right? So I know it's got to be one of those. And do you agree we're increasing here? Yep. So that's A. And then we are concave down on that same section, K to P. So you're going to say your rate of change is what? Increasing or decreasing? No, D. So up is increasing. Good, Jackson? Okay. Steady, my darlings.